Hi, hi, folks. I wanted to here. Let me turn my light on here. Sorry about that. Kind of in the dark. Um, I wanted to show you what I'm kind of thinking about for this assignment and how your proposed synthesis should look. Okay, here's the assignment up on my screen, and what this is called is a retrosynthesis pathway. There are several ways to perform this type of retrosynthesis on these reactions, on these reactants. I'm just going to give you the most complicated pathway I could actually think of, because you wouldn't likely come up with this particular pathway to make hexan-3-one. So I want you to try a different approach. What I'm going to do is to set this up is draw hexan-3-one. Okay, so we got to have a starting point. So 1, 2, 3, 4, 5, 6 carbons, and on the third carbon we have our ketone, hexan-3-one. All right. So there, like I said, there's multiple ways of constructing this molecule, but I want to ultimately break it up, and so that I'm looking at just 3 carbon alcohols, or 2 carbon alcohols, or a single carbon alcohol that's generating this overall look. Okay, so what I need to think about as I'm approaching this is, how can I make a ketone that will look like this? All right. And again, like I said, there's more than one way to do that. I'm picking the most convoluted way that you could possibly use, just because I won't expect you to have come up with that. So with a retrosynthesis, what you're doing is you're trying to pull this apart and come up with a reaction that will, in the forward direction, give you this. Now, it might give you other things too, but will give you this as a major component. So what I was thinking is that I could end up with this if I did an oxidation of an alkene, a cleavage reaction. Okay, so what I would start with, 3, 4, 5, 6, is I would start with this alkene. Okay, and I could really have anything on this side over here, but I need 3 carbon alcohol. See what I'm saying? Okay, so 1, 2, 3. So if I were to react this reactant with sulfuric acid, if you remember your ketone or your alkene chemistry, we can use a cleavage reaction here that will then cleave here, put an O there and an O there, and so on. Okay, and that reaction is with KMnO4 and acid. Now, I like to use sulfuric acid, but it doesn't have to be sulfuric acid. But the key there is the KMnO4. Okay, and it needs to be the acid so that we get the cleavage instead of the diol. Okay, so if you recall in that reaction, this bond here would break, and we'd end up with 2 ketones, and one of those ketones is the product that I want. All right, so that's the proposed step to get the end result. So now I've got to figure out how, using chemistry that we've learned, to make this, okay, this alkene. So to make this alkene, we can use an elimination reaction. If we're going to do an elimination reaction, then we need to have an alcohol that we can, or some kind of a alkyl halide that we can have as a leaving group, and go through an elimination reaction, and this being our Zysol product. Okay, so with this cleavage reaction, I'm going to use an alcohol because I've already got it set up here. 1, 2, 3, 4, 5, 6. So we're going to have this alcohol, which is basically isopropanol on this side, which is my 3 carbon alcohol that I can start with. And then we were going to want to make it more better leaving group. So we would protonate it, make it water, and then it would leave, creating a double bond here. And to make that happen, we would just use sulfuric acid and some heat. Okay, so that reaction would, using this as a reactant, we would then be able to take this alcohol. It's a pretty complicated alcohol, but we'd be able to take this alcohol and do an elimination reaction, probably E1 to get this, and then from there we would oxidize it to our ketone. Okay, so that's the kind of thing I'm thinking about with this retrosynthesis. Like I said, this is overly complicated. So now I need to make this. So I need to think about how I would get an alcohol from a reaction. Okay, so we can make, this is a tertiary alcohol. The only way that we know how to make a tertiary alcohol is through a Grignard reaction. Okay, and through that Grignard reaction, we would be able to take isopropanone, which would be our ketone, okay, and then we'd need an alkyl halide Grignard reagent, and that would be this end of it. So the 1, 2, 3, 4, 5. And then at the third carbon, we would have our Grignard reagent, and that would then react at this carbonyl carbon, as we've learned a couple of different times with this ketone, this carbonyl carbon, and we would end up with this alcohol in the end. Okay, so these two would react with each other directly. I wouldn't need any other reagent there, but these two would create this. So this then, how would I make this from an alcohol? Because I need 3 carbon alcohols, not a 3 carbon ketone. All right, so now I'm branching off. Okay, this is going to need to be constructed independently. This is going to need to be constructed independently. So I need a different molecule then that would create this, and this of course would be just a standard alkyl halide. I think I said Zeitz-Sol. It should be Zeitz-Sif product up here with the double bond being between the more substituted double bond. So this plus magnesium would give me the magnesium bromide piece. So this is creating the Grignard reagent. Now here, I need to oxidize basically an alcohol. So if I had OH, isopropanol here, then I could oxidize it with just about anything, KMNO4, chromate, dichromate, just about anything, good oxidizing reagent would create this ketone. And then if I could figure out how to make this from nothing but 3, at the most 3 carbon length alcohols, and it looks like I could do that with possibly two different alcohols here. Okay, but I need to be able to make this now. Okay, so in order to do that, well, what would I would probably take an alcohol, and with PBr3 would end up brominating it. Okay, so I need this alcohol. Then with the PBr3, I'd make this. Then with the Grignard reagent, I would make the Grignard reactant, I'd make Grignard reagent. Then with this ketone, I could make this alcohol. Then I could do the elimination reaction and oxidize it ultimately, or cleave it ultimately to the ketone. So this is the kind of thing that I'm talking about with this proposed synthesis. How would you get this from a bunch of little pieces? Well, so now I'm here. Okay, I'm at a 6 carbon alcohol with the alcohol on the 3rd carbon. So how would what kind of reaction would make this secondary alcohol? And I could produce this secondary alcohol if I started with components that were Grignard based, so like a carbonyl. Okay, so 1, 2, 3 carbon carbonyl, and then hit it here would make a secondary alcohol. I didn't want to put another R group on here, that would make a tertiary. Okay, so I could have my Grignard reagent react here, and that would give me 2 carbons on one side, so like this. So I need an alkyl halide then that is this component. All right, so that's a 1, 2, 3 carbon aldehyde, and I would have to come up with a way to make that specifically. And to make that aldehyde, so I still need a Grignard reagent here, but to make this aldehyde, I would just use PCC from a propanol. That's so 1, 2, 3, and then PCC would react and oxidize that into this component. So that's a 3-carbon alcohol. This is a 3-carbon alcohol. And my alkyl halide could ultimately be made from a 3-carbon alcohol. Okay, but I need a Grignard reagent to react here, and I need it to be 3 carbons. So here's my Grignard reagent, 1, 2, 3 carbons. I would react this with this, and that would put this tail on this alcohol. So the 1, 2, 3 carbon tail. And this already has 1, 2, 3 carbons on it, 1, 2, 3 carbons on it. Okay, so that would give me the secondary alcohol that then I could lace with bromide, make a Grignard reagent, react with a ketone made from a different alcohol, and so on. So now I got to figure out how to make this component. Okay, so how do I make the magnesium bromide? Well, I've got to start with a bromide. And that bromide then could be made by lacing an alcohol with PBr3 again. And that alcohol would be that alcohol, 1, 2, 3 carbons. Throwing PBr3 at it would make this alkyl halide. Take that alkyl halide and add magnesium, and I would end up with this Grignard reagent that would react with this aldehyde, and it will work its way through. So this is a proposed synthesis. This is called a retrosynthesis. And it's called a retrosynthesis because I started retro. I started with the original compound and started pulling it apart. Or how do I make this? Well, I could make this from this reaction. How do I make this? Well, I can make this from this reaction. How do I make that? Then I continue to pull it apart piece by piece by piece, reverse, until I end up with my components that I said that I was looking for. Okay, 3 carbon alcohols. At most, I could have used a single carbon alcohol and so on. So every piece originally, every step of this pathway would have originally started with the reagent. The original reagent would have been at most 3 carbons long. All right, so that's one proposed retrosynthesis of this hexan-3-one. All right, so now you need to come up with a retrosynthesis of hexan-3-one. There are more than one way to create a ketone. Like I said, I did the most complicated way imaginable. You can still use some of the steps that I used, but you can't do this same original step or two. Okay, you need to come up with another way to end up with this ketone. And you could end up with an alcohol here and just oxidize it instead of a alkene and cleave it. That's the kinds of things that I'm talking about. Okay, you could start with a triple bond and work with that triple bond using a cleavage reaction, something like that. All right, so any of those options are available. You just can't use this exact same retrosynthesis. All right, that's the kind of thing I'm looking for. Hopefully it makes sense. If you have any questions, let me know. But you're going to propose these synthesis of these 3 molecules and upload them in the assignment. All right, good luck.